Hello everyone. In this session, I'm going to discuss aggregate expenditures. So before going to show you the learning objectives of this chapter, let me quickly review what we did last time in aggregate demand and aggregate supply model. So if you remember, we talked about that this is a downward sloping aggregate demand curve. This is an upward sloping aggregate supply curve. If you remember, this is real GDP on the horizontal axis, price index on the vertical axis, and this point of intersection was the equilibrium uh, GDP. That is, the economy is at equilibrium. So I'm not going to review everything in today's session, but what I'm interested in explaining this aggregate demand. You know that aggregate demand is consumption expenditures plus gross investment expenditures plus government expenditure plus net export XN. And by net exports and XN, I mean exports minus imports. Okay, so this is net exports. What we are going to do in aggregate expenditures, we will only focus this aggregate demand in more detail, because when we talked about equilibrium GDP, that is this written here as YE, I did not calculate any numbers there because we just talked about aggregate demand and aggregate supply in general terms. What we are now going to do, we will further examine this aggregate demand curve in a slightly different way. So what we are going to do in today's session, instead of calling this aggregate demand, I call it aggregate expenditures. Aggregate expenditures are actually aggregate demand. Why? Because, when you demand something, it means you are spending money on that product. For example, if I say that my demand is one laptop, suppose, so basically I'm going to buy that laptop, and that would be my expenditure on that laptop. So this is how we measure aggregate expenditures. So we add, and remember, when we calculated GDP using expenditure approach, I told you that time that we just add all expenditures, that is consumption expenditures, investment expenditures, government expenditures, and expenditures by foreigners, that is net exports. So when we were talking about aggregate demand and aggregate supply model, on the vertical axis, we took price index because demand is related to prices. When price index increases, aggregate demand decreases. We discussed this earlier. Now we are focusing only on aggregate expenditures. Notice there's no price involved right now because I know that aggregate expenditures are nothing but the summation of all these four terms, that is consumption expenditure, investment, government expenditures, and exports or net exports. So in this chapter, what we are going to do, I will take each of these components of aggregate expenditures and further analyze these four different components, and then we add them together and derive aggregate expenditure function. And then we move on from there and we calculate the same YE once again. Okay, so let's start this topic. So these are learning objectives, and these are some of the terms that we should understand, which I'm just reading out. Um, Describe the marginal propensity to consume. We'll discuss what do we mean by marginal propensity to consume and how consumption, saving, and investment relate to national income. By national income, I mean GDP. Explain the concept of expenditures equilibrium. We already calculated equilibrium GDP using aggregate demand and aggregate supply curves. Now we will calculate equilibrium using expenditures, and this is what we call expenditures equilibrium. Explain how the multiplier produces big changes in national income as a result of small changes in spending. So I'll also discuss the formula for calculating multiplier, and we see how we use the concept of multiplier to determine the impact of an increase in any of these four components on equilibrium GDP or real GDP. And finally, I will derive aggregate demand that I showed you the outset when I started this session. I just had drawn a downward sloping aggregate demand curve. So we will derive that aggregate demand curve using aggregate expenditures, and you will see. So let's start. So this is basically the complete aggregate expenditures model. Let's discuss all these components one by one so that you understand. Okay, you all know that aggregate expenditures equal these four components. That is CIG plus G plus exports minus imports. This times I wrote M as imports. You could have written IM as well. Doesn't make any difference. Okay. And then I write once again this C, gross investment, government expenditure. Instead of writing this whole X minus M, I just wrote XN as net exports. So net exports mean exports minus imports. So aggregate expenditures equilibrium. What is the equilibrium? The equilibrium point, I know in the previous chapter, equilibrium is when aggregate demand intersects aggregate supply curve. Here, aggregate expenditures would be equal to when your income, that is GDP, so I'm writing in the bracket, when your GDP is exactly equal to aggregate expenditure. This is the meaning of expenditures equilibrium. For example, if Canada produces $1 million worth of goods and services in one specific year, let's say 2022. So in 2022, the total value of all final goods and services produced within the boundaries of Canada was $1 million last year. Then that $1 million GDP would be equilibrium GDP if the aggregate expenditures, that is consumption expenditure during the same year, government expenditures, investment expenditures, and net export must also be equal to $1 million. That is the condition, equilibrium condition. So for example, let me give you a very simple example. Like suppose if I produce one product and the value of that product is $100, then I have to have $100 expenditures as well, so that I can sell that product, because whoever buys my this product will pay $100. So his or her her expenditure would also be $100. That is the value of my product. It means there's no discrepancy, right? So whatever is being produced being sold out. So that is the best situation, and this is what we call equilibrium GDP or expenditures equilibrium. Okay, and don't worry, we will calculate this equilibrium GDP or expenditure equilibrium. But remember this equilibrium condition, that when Y means the value of total production, and aggregate expenditure means expenditures by all those four different groups on this production. That is Y. If they both are equal, that is equilibrium. Now, once we know equilibrium, expenditures equilibrium, once we know aggregate expenditures, now what we are going to do, we will actually study all these components individually. How? First, we start with consumption. What is consumption expenditure? So we write consumption function, and this is the simplest form. Okay, so consumption function is given as And I've taken these numbers so that you know what I'm doing. It will help you understand how to calculate equilibrium. So consumption, capital C is consumption expenditures, equal 50 plus 0.75 YD. YD is disposable income. This is only Y, remember. So this is the GDP. YD is the disposable income. And you know how to calculate disposable income. So if you subtract taxes from your income, you will get disposable income. Okay, we'll do this in a moment. Now we further discuss this consumption function. This is the simplest form of consumption function for this introductory course. I'm just adding all types of consumption in just one function. Otherwise, you would have different consumption functions. So consumption functions for durable goods, consumption functions for non-durable goods, consumption functions for services, all these different consumption functions. But I assume that there's only one consumption function, and it includes consumption of all goods and services that consumers are actually buying. What is this 50? And remember, this is not individual consumption function. This is not consumption function for one individual. This is for the whole country. What is 50? Let's say $50 million. So $50 million is the amount of expenditures that consumers are actually spending in the country that is independent of their income. It has nothing to do with income. So even if your income is zero, still you are going to consume on basic needs. For example, you need to eat something, so you have to spend on food, you have to spend on basic necessities even if your income is zero. Then how you are going to afford? Of course, you can borrow money or you can use your savings. So if you have your savings, even you are not working, your income is zero, but you can use your saving and make those purchases that are absolutely necessary. So there's a specific term for this $50 million. This is called autonomous consumption. So remember this word autonomous. By autonomous, I mean independent of the variable that is included in the function. Okay? Just give me a second. So here in the function, YD is another variable. So 50 million is the consumption level that is independent of disposable income. So this is fixed. It has nothing to do with your disposable income. So if your income, if the Canada's per capita income is increasing, doesn't matter. This 50 is a fixed number. That is called autonomous consumption, $50 million. Then we have this coefficient of, let me first erase this so that I can, now just give me a second, right? Let me fix this once again. Yeah. Now let's see this. So this, this coefficient only 0.75. This coefficient is called marginal propensity to consume. And in short, we always write MPC. What is MPC? The formula to calculate MPC is change in consumption divided by change in income. Should be disposable income, but income means, which I have taken here, YD, okay? Change in income, that is 0.75. What is the meaning of this? It means whenever your income increases by $1, your consumption will also increase by 75 cents because the value of MPC is 0.75. So every $1 increase in income will lead to 0.75 cents or 0.57, not 0.57 cents, I'm sorry, $0.75 increase in consumption. So 75% of your increased income will be spent. This is the meaning of marginal propensity to consume. So for example, if your income increases by $100, then $75 out of that $100 will be spent on buying goods and services, right? That is consumption expenditures. So this is the value of MPC. If I add these two together, that is this whole term, 0.75 YD, this whole term, this term is called which is not mentioned here in this slide. This is called induced consumption. So you have basically autonomous consumption 50 and then induced consumption 0.75 YD complete. So you can see in consumption function you have two components. 50, that is autonomous consumption. The second component, the everything included, right? 0.75 YD, income is also included. That is called induced consumption. The coefficient of YD is called marginal propensity to consume. So if a person, or if normally it's not a hard and fast rule, but for poor people, so for poor people with very low income, their MPC is very high, because when they earn income, they spend most of them on buying goods and services. For rich people, the MPC is low. Why? Because when they receive income, they save, they invest as well. Excuse me. And therefore, they consume less proportion of their income as consumption expenditures. Okay. Then we have another term. So that's all as far as consumption function is concerned. So we just assume that consumption function is 50 plus 0.75 YD. But the problem is we have YD here. YD, that is disposable income, I told you is actually Y minus taxes. That is total GDP for the whole country. And then you subtract all taxes. That is basically disposable income. So but we are interested in this capital Y. We are not interested in YD. So I have to convert this YD into Y. So instead of YD, I can write Y minus T instead of YD. Therefore, I should know what is T. That is defined here. So if you see here, we know that YD is equal to YT, which I have already underlined. Now see, suppose taxes is given as well. And tax is a function, this is called tax function, very similar to consumption function. This is 60 plus 0.2y. I know what is 60. Autonomous taxes. Remember the word autonomous. Autonomous means independent of income. So some taxes are not dependent on your income. There's so many other taxes as well, property taxes and other different taxes. But income taxes are also there. That income tax depends on your income. So this 60 is induced or autonomous, taxes, and this whole term 0.2y whole term is called induced taxes, like induced consumption. And this coefficient of income that is only 0.2, this is called marginal tax rate. We don't call marginal propensity to tax like marginal propensity to consume, but the idea is same. But we call it marginal tax rate, MTR. What is marginal tax rate? Is 0.2. 0.2 means basically 20%. That is, whenever your income increases by $100, suppose you have to pay 20% taxes on that $100. So this is the example. I know we have a progressive tax system. So if your income increases, your tax rate changes as well. Remember? So if you're earning, I don't exactly remember those numbers, but if you're earning some 40,000, less than 40,000, the marginal tax rate is 22%, that's say 0.22. But if you are in higher income bracket and you earn $100, then you have to pay higher tax rate. Okay. But here we are assuming that marginal tax rate is constant. So even if you are a millionaire and if you earn $100 extra, you have to pay 20%. But in reality, those rich people, they have to pay up to 40, more than 40% taxes on their additional income. After that, income, if you are in a specific income bracket. Anyways, that is not the point here. So because in order to make this model simple, I am assuming that MTR is constant, that is 0.2, which means 20%. Then we have saving function. Saving function is exactly opposite of consumption function. Okay. So see this. Consumption function is already given here. So let me underline this consumption. This is consumption function. So saving function is, you know, that if you remember that your disposable income is. So saving function is, you know, that if you remember that your disposable income is either consumed or saved. There's no other purpose other than consumption and saving. So whatever you don't consume is your saving. That is the meaning of saving. After, of course, paying all taxes, because I'm talking about disposable income. So saving function is, with this 50, when you spend this $50 and your income is zero, that is the meaning of autonomous consumption, that even if your income is zero, you still are going to consume 50. Where does this $50 million come from? You are not earning anything. So you must actually use this $50 million from your savings. So your savings will decrease by $50 million. So that is why when your income is zero, your saving is minus 50. Why minus? Because this is dis-saving. You are not saving. Your saving is actually decreasing by $50 million. Your means for the whole country, not individually. I'm not talking about microeconomics here. So that is minus 50. Now, when your income increases YD by $1, you are going to spend 75 cents out of that $1 on consumption. The remaining 25 cents you must save. So 25 cents means 0.25. So that is 0.25C, 0.25, and then YD. So the rule is, whatever number is written here, just write with a negative sign. Whatever number is written here, just subtract this number from 1, because you know that is the whole dollar. So 0.75, so 1 minus 0.75, 0.25, just write 0.25 here, and YD. Again, minus 50 is autonomous saving, or you may call it dis-saving because it's a negative sign. This whole 0.25 YD is induced saving, and this coefficient 0.25 only, that is 25% basically, is called marginal propensity to save. In short, we normally write like this. So MPS, this is marginal propensity to save, that is equal to 0.25. Since this 0.25, I've calculated this by using this formula, 1 minus 0.75. What is 0.75? Is actually taken from here. So 1 and then this marginal propensity to consume will give me 0.25. And remember, 0.75 is what? MPC. So I've calculated MPS as 1 minus MPC. So if this is the rule, then I know MPC plus MPS must always be equal to 1. Okay? And this is a simple derivation. So I don't have to actually show you, but let me show this. So I know that MPS is equal to 1 minus MPC. This is how I calculated 1 minus 0.75 equal 0.25. So if you this minus MPC, if you take this to the left hand side of the equation, this would be MPC plus, because this is minus. So here I have plus sign, and then this MPS is already here, MPS, and then you have only 1 remaining here. So MPC plus MPS equal to 1. This is what I'm showing here. Okay. So now, so far, what we have so far done, we have shown you the consumption function, the form of the consumption function, 50 plus 0.75 YD. I also showed you this tax function, which is by assumption 60 plus 0.2Y. And I also derived actually or calculated saving functions using consumption function. And we also discussed autonomous part and induced part. Now let's move to. So now I am going to give you all the detailed information, because using consumption and saving functions, I just discussed the meaning of autonomous, marginal propensity to consume, marginal propensity to save, marginal tax rate, tax function, saving function. Now I write all these components, right? And these are simple equations, this is basically the assumption, right? So we are assuming that these are the values, just to make to help you understand the simplest model, aggregate expenditures model. Okay, so let's see this. So I told you that aggregate expenditures basically are these four components. I have already discussed in detail this component, consumption function, if you remember. I haven't talked about IG, G, X minus M. Remember, there are no taxes here. T is not here in this whole aggregate expenditure equation. Actually, taxes are hidden in consumption. Because remember, consumption is what? Consumption is 50 plus 0.75 YD. And what is YD? YD is actually Y minus T. So taxes are here. So later on, we will plug these taxes here in consumption, don't worry. Then now talk about investment. So if I talk about investment the same way as consumption function, that we have autonomous investment, we have induced part of the investment, what are the factors that determine investment? Of course, income may be, but interest rate is the most important factor determining interest rate. Similarly, government expenditure, then the model will be very complicated. So what what I'll do, I assume that gross investment is autonomous only. There's no induced part. So there are no other variables. So what I assume that investment is just equal to $75 million. So investors are investing $75 million in a specific year. Finish. It has nothing to do with what is the interest rate, what is the political situation in the country, what are different government policies. Our government policies are conducive for investment in the country or not. There are so many other factors, but we are just for the sake of simplicity, we're assuming that investment is autonomous, $75 million. Similarly, we are also assuming that government expenditures are also autonomous, but not necessarily. But we are assuming here that government expenditures or government spending is also autonomous, and the number is $160 million. You could have taken any number, right? So there's no significance of this $160 million. You could have taken $500 billion. Okay, doesn't matter. But just for the sake of simplicity, I'm taking smaller numbers. So 160 million. Similarly, we also assume that exports are autonomous. So exports equal $100 million. So basically, you are exporting goods and services worth $100 million to the rest of the world. Of course, exports will depend on the foreign's real GDP. If real GDP, if per capita income in US is increasing, it means Canada is now going to export more to US because now they are demanding more products because of their higher income. We are not discussing this. We are just assuming that everything is held constant and our export is fixed at $100 million, whatever be the income per capita in United States or in other importing countries. But for imports, we take a function. So we could have taken import as autonomous import simply, but here we take imports as a whole function like consumption function, if you remember. So 40, any number, I just wrote 40 plus 0.1 y. What is 40? 40 is autonomous imports. That is independent of your income. Of course, this is import. So if our per capita income is increasing, we are going to buy more foreign products. So import will increase. So this is 40 is independent of income. We're just buying foreign products. And then the second part of this equation, whole 0.1y, is called induced imports because this is induced due to income. And this coefficient 0.1 is called MPM. And you know what is MPM? Like MPC, like MPS, now we have MPM, marginal propensity to imports. MPC is marginal propensity to consume. MPS is marginal propensity to save. MTR is marginal tax rate. So MPM is equal to 0.1. What is the meaning of this 0.1? 0.1 means when Canada's income increases by $1, we are going to import or buy goods and services from outside Canada worth of $10. That is 10% of our increased income. So if GDP per capita income is is increasing in Canada, then that increased income, 10% of that income will be spent on buying foreign goods and services. This is the meaning of point one. So basically, we are importing 10% of our GDP. Okay. Now, once you know this, then we set up everything and calculate equilibrium GDP or expenditures equilibrium. So let's discuss this equations. I know these are confusing, but at the end of these slides, I've given you one example that you have to solve. Okay, and you can also see practice questions as well on this topic. So let's see this first, and I'll go step by step. And I have shown you everything, so you have to remember this sequence. This is important. Number one, we know that at equilibrium, Y is equal to aggregate expenditure. What is Y? GDP, total value of your GDP. So if you are producing $2.8 trillion worth of goods and services, then at equilibrium, your aggregate expenditures must also be $2.8 trillion, so that consumers, government, investors, and foreigners, they can buy those $2.8 trillion worth of goods and services. But it is not always the case. Sometimes aggregate expenditures are less than the total value of goods and services produced. Sometimes aggregate expenditures are more than the value of the total goods and services produced in the country. So I'll discuss that inequality as well. But first, let me calculate how to calculate basically equilibrium real GDP. So we equate Y equal to AE. So the only problem is I have to calculate what is AE. And you all know that AE is actually C plus IG plus G plus X minus M. Just plug all these values. So for C, just write consumption function. For IG, just write 75. For G, just write 160. Export, I don't remember. And imports, the whole function. So this is what I've done here. See this. So first I write Y equal to, instead of aggregate expenditure AE, I write 50 plus 0.75 YD. This is consumption function, if you remember. Then investment is autonomous, 75. Then government expenditures, autonomous, 160. Then exports, autonomous, 60. Oh, no, hold on. Then this whole thing is exports minus imports. How? Let's see this. Let me show you here. What is export? Let me see. Export is 100 if I'm not wrong, but let me double check. Export is 100, 40 plus 0.1. Okay. So export is 100, okay, minus imports is 40 plus 0.1 Y. This is import. But this is a negative sign. So when you open this bracket with a negative sign, everything will be negative. So you write like this. So this is export. Hold on. I thought it's working. No, it's not working. Hold on a second. So this is basically exports minus imports, right? 100 minus, and in the bracket 40 plus 0.5. So with a negative sign, when you open this bracket, it would be 100 minus 40, and then don't write plus, minus 0.1 Y. And then 100 minus 40, I know is 60. And this minus 0.1 Y. So this is written here. 60 minus 0.1 Y. So that is this minus 0.1 Y. So this is written here. 60 minus 0.1 Y. So that is net exports. So I just subtracted imports. Remember, when you write aggregate expenditure in this way, then you have a negative sign before 0.1. Although in the import function it is positive. Don't get confused. See this. Here in import function, this is plus. It cannot be negative. When your income increases, you are going to import more. So it's plus sign, must be plus. But when you subtract this whole amount from 100, it would become negative number. Okay. But again, the problem is in this equation, this equation, let me see it. Let me show you. Oh, sorry. If you notice in this equation, I have YD and I have to get rid of this YD because I'm not interested calculating YD. I'm interested in calculating Y that is on the left hand side of the equation. So I want to get rid of this YD. How? I know that YD, that is disposable income, is nothing but Y minus T. So I write Y minus Y. I have to calculate this Y minus T. Tax function is given. We know what is tax function. So I can show you here. I've already assumed that our tax function is 60 plus 0.2y. So this is what I'm going to do, that I will insert here. Now see this. So I write, first I write 50.75 and instead of this YD, I write Y minus T, and then all the numbers are same, 50, 160, 60, minus 0.1. And then instead of this T, I plug the tax function. So I write same 50, same 0.75, same Y. Instead of T, I write 60 plus 0.2Y. So, but since there's a negative sign before T, so I have to write all negative numbers. So Y minus 60 minus 2.2Y. Don't write like this, Y minus 60 plus 0.2Y. That is incorrect. Y minus 60 and minus 0.2Y. Plus 75 plus 160 plus 60 plus 0.1, all the numbers. Now open this bracket. Open this whole. So before opening this bracket, what you have to do. So this is how I open this bracket. 50, same 50. Then I open this bracket with 0.75. So 0.75 times Y. This is 0.75. Then 0.75, 60. So minus 0.75 times 60. And then this is also minus. So 0.75 into 0.2, 0.75 into 0.2. And then this Y, and this Y. 75, 160, 60, same. Once you open this bracket, you can solve. Just multiply. So 50.75 Y minus 45. I know if you use your calculator, 60 times 0.75 is 45. Then 0.75 multiplied by 0.2 is 0.15. 75, 160, 160, and then 0.15. Now, why I have written these numbers in red, 0.75y, 0.15y, 0.1y, because I'm interested in only y terms now from the right hand side of the equation. Why? Because first I take all y and take all these y to the left hand side of the equation because I want to calculate the value of y. So all these red y terms you can add or subtract, based on the plus and negative sign. So see this, 0.75 and minus 1.15. So you have to subtract 0.15 from 0.75. So 0.7, it would be 0.6. And there's another 0.1 here with a negative sign. So 0.6 minus 0.1, 0.5. So that is why I wrote 0.5 here, 0.55. And then all the constant number that is without y term, that is autonomous, just add or subtract depending on the sign of the of that number, whether positive or negative. So see 50 and then minus 45 plus 75 plus 160 plus 60. If you do this, so add all numbers and then subtract 45, you get 300. So this, and that's why I bold it, this y equal to 300 plus 0.5y. Actually, this is this equation I started. So basically, if I write here 300 plus 0.5y, this is basically your aggregate expenditures. And you equated this aggregate expenditure with y. That's why you are writing y equal to 300 plus 0.5y. Okay. So now you have y on both sides of the equation, if you notice here. So just consider the bold part of this. That is this. Let me mark this. So y equal to 300 plus 0.5y. We have to calculate y. So I take this, and this is very important. This is plus 0.55. Take this to the left hand side of the equation here. So this y is same as this y, and then this 0.5y comes here with a negative 0.55. You have to change the sign, and then 300 is same on the right hand side of the equation. Then y, remember, if I write y always means 1y. Remember, we don't write 1. So this is 1y minus 0.55. So 1 minus 0.5 is 0.5, which I've already written here. So 1 minus 0.5y equal to 300. So 1 minus 0.5 is also 0.5, luckily. So y equal to this 300 and divided by this 0.5. Don't get confused. This 0.5 is not this 0.5. Because with 0.5, when you subtract 1 minus 0.5, that is why you get 0.5 here. And then y equal to 600. So this is the equilibrium level of income, that is $600 billion or $0.6 trillion. Now, let me give you the rule so that you don't make this mistake in your midterm exam and also in your assignment. Let me give you another aggregate expenditure function. So suppose aggregate expenditure, I just showed you how to derive this aggregate expenditure with all this data. So I'm just giving you a number, different number. Suppose this is 400 plus 0.6. Suppose this is aggregate expenditure. So I've added all incomes and I get 0.6y, and then this is autonomous part. Autonomous consumption, autonomous investment, autonomous government expenditures, and autonomous exports, and autonomous imports as well, because there was a part of autonomous import 60, if you remember, although we subtracted because we calculate net exports minus imports. So we have to subtract autonomous imports. Anyways, if you have this and I ask you calculate equilibrium, so first thing that you have to do this, y equal to E. This is the equilibrium condition, which is written here. And then y, you just write as it is. And instead of AE, just write this equation, 400 plus 0.6y. Now, even if you are not comfortable with solving this equation, if you are not comfortable with this calculation, then I'll just tell you the rule. And then you have to remember that rule. The rule is that equilibrium income, so I write YE as equilibrium income. The rule is always write this number first, 400. So write 400 here in the numerator, and then divide by which number? Not 0.6. I know that students make this mistake often. Don't divide by 0.6 because you actually memorize this, that since 0.5 is here and that is why divided by 0.5. No, whatever number is given here, that is 0.6, just subtract this 0.6 from 1. So 1 minus 0.6 is 0.4, then divide by 0.4. When you had 0.5, 1 minus 0.5 is also luckily 0.5. That is why we divided by 0.5 here in this case. But here, this is 0.6. So 1 minus 0.6 is 0.4. So 400 divided by this is 0.6. So 1 minus 0.6 is 0.4. So 400 divided by 0.4. Okay. And then you calculate. I don't know what this equal to, but you can calculate 400 divided by, let me see, 400 divided by 0.4, you get 1000 equilibrium. So the value is 1000. Equilibrium value is, equilibrium GDP is 1000. Let me delete this, and then on this slide I have just one last topic. Once you calculate aggregate expenditure, this I'm writing here. Once again, aggregate expenditure is equal 300 plus 0.55. Once you calculate this, you can easily calculate equilibrium income without making, going all this calculation. This is how you write YE equal to this first number, 300, and then divided by not this number, 1 minus this number, which is actually also 0.5. So you will get this as 600. Okay. So let me write this equation, that is aggregate expenditure, although it's not separately mentioned in this slide, but notice that actually aggregate expenditure is 300 plus 0.55, this aggregate. So we have also the same term. This 300 is called autonomous expenditures. Remember, like autonomous investment, autonomous consumption, autonomous saving. This is autonomous expenditures. This 0.5, only this coefficient. This is not MPC, marginal propensity to consume. This is not marginal propensity to imports. This is not marginal tax rate. This is not marginal propensity to save. It has a different name. This is called marginal propensity to expend. So this is called marginal propensity to expend, MPE. So MPE is nothing but the coefficient of Y in aggregate expenditure function. Okay, so in aggregate expenditures function, the coefficient of income is called marginal propensity to expend. Let's go to the next slide. So this is what I just discussed. Let me just go through again. So you know that this is aggregate expenditure, 300 plus 0.55. Marginal propensity to expend, MPE, is 0.5. How do I know? Because this is 0.5 here. Then we have, again, like marginal tax rate, we call it marginal leakage rate, MLR. I know there are too many terms in this chapter. What is MLR? MLR is exactly 1 minus this number, MPE. So MLR is 1 minus MPE. And luckily, since 0.5 is MPE, so 1 minus 0.5 is also 0.5. So in this case only, not in all the cases, MPE and MLR both are equal to 0.5. Once you know these coefficients, these ratios, marginal propensity to expend, MPE or MLR, then we can calculate the value of multiplier. So the value of multiplier is, the formula is this. Remember this formula. 1 over 1 minus MPE. 1 over 1 minus MPE. And I know that 1 minus MPE is nothing but MLR. So I can also write this formula as 1 over MLR as well. And I can calculate because I have both data, MPE and MLR. So 1 over 0.5 is 2. So the value of multiplier is 2. Okay. So the value of multiplier is 2. Now let's see how we use this value of multiplier in the next slide. But before going to go and just discuss this, I think this is in the example. Okay, just wait. I will come back to this topic again. Now I know I told you that at equilibrium, Y is equal to aggregate expenditures. This is the equilibrium condition. There's another equilibrium condition, and that equilibrium condition is that, remember in circular flow of income model, we discussed leakages and injections. So at equilibrium, we know that all leakages must equal to all injection. That is also the equilibrium condition. That is another equilibrium condition. So if all leakages are equal to all injections, then automatically Y will also be equal to AE. So why not we check this? And it is important, but I'm not going to spend too much time on this. So leakage, you know that leakages are first savings, taxes, and export. These are leakages. For exports, it's so first saving, you know saving functions if you remember. So we use saving function and calculate savings. Remember, saving function was what? Minus 50 plus 0.25 YD. And instead of YD, I'm writing Y minus D. So we have already calculated Y, if you remember, equilibrium Y, which is 600. And taxes, you have to calculate taxes again. What was the taxes? I know it's confusing, but taxes is 60 plus 0.2 Y. And I know Y is also 600. So 600 times 0.2 is 120 plus 60, 180. So see, this is 180. So instead of YD, I write 600 minus 180. And this should be in the bracket. Yeah, this is bracket is Actually not visible. Let me clear this. So this is in the bracket, okay? So 600 minus 180 times this is saving, and then tax function is this. Why I keep writing y as 600? Because I've already calculated equilibrium level of income, that is 600. And exports is autonomous, independent of income, 100, which we know this. So this is equal to 335. Now, what are injections? Investment is much easier to calculate because this is autonomous, that is 75. Government is also very easy to calculate, autonomous, 160. Now we have to calculate imports. We know the function. Imports function was 40 plus 0.1 y, and instead of y, I just wrote 600. So if you can add all this term, you will again get 335. See, both are equal. So they will always be equal at equilibrium. How do I know at equilibrium? Because I kept using y equal to 600. So I'm calculating all these leakages and injections at that level of income, 600. And I know that since 600 is equilibrium, and therefore it should be, they both should be equal. Now this is the example, and here we will use the concept of multiply. There is, so you can see, if government expenditures increase by $10 million. So suppose government increases its expenditures by $10 million. What is the change in income? What would happen? I know that right now the income was, is $600, if you remember. In the previous slide, I calculated this. So let me just write for your convenience here. So if you remember, aggregate expenditure that we calculated was 600 or no, it was 300. I'm sorry. Let me erase this. So aggregate expenditure was 300 plus 0.55. This was the aggregate expenditure. Using this aggregate expenditure, you can calculate multiply. I know what is multiply. So multiply, sometimes we write as a small k, 1 over 1 minus MPE, or 1 over multiply, sometimes we write as a small k, 1 over 1 minus MPE, or 1 over MLR. And I know MPE is 0.5. So MLR is also equal to 0.5. So 1 over 0.5 equal to 2. So I know that multiplier is 2. Okay. Now, if government increases its expenditure by $10 million, this increased expenditure, $10 million, will be added here in 300, right? Because it's autonomous, just increase by 10 million. It doesn't say that government increases 10% of the total income. Now, there's a problem, but it's a fixed number, $10 million. So I just add this $10 million here. So instead of 300, it would become 310. So new aggregate expenditure would be how much? 310 plus 0.55. And I told you, if aggregate expenditure is this, how you can calculate equilibrium income. It's very easy. So equilibrium income is, I told you, write this number in the numerator, 310 this time, divided by not this number, 1 minus this number, which is in this case also 0.5. So 3 divided by 0.5. So this is equal to 620. Okay. Now notice, before the increase in government expenditures, I know, you know as well, that equilibrium income was 600. Now notice, with the increase in G by 10 million, the GDP increases from 600 billion to 620 billions, not 610 billion, 620 billions. It means we have a multiplier effect. Multiplier effect means government increases only $10 million, but income of the whole country increases by $20 million. Why? Because when government increases its expenditure, this expenditure is someone else's income, and they are also going to spend this money. So there is a chain of more expenditures, not just this initial $10 million. So how do we calculate this? We multiply this 10 by this multiply. That is the concept of multiply here. So basically, when I calculated multiply equal to 2, it means whatever increase in G will be multiplied by 2. So the impact will be double. So when government increases its expenditure by 10 million, income, this 600 will increase by not 10, but this 10 times is multiplied to 20. So that's why we have 20 million increase in real income. Let me show you here. So this is the answer. I just added first plus 10 here, and then I calculated the same way. I get 620. I can check this. I know the multiplier is 2. So an increase in G by 10 will increase Y by 20. So change in Y would be multiplied. Change in Y is 20, I know, because 600, from 600 to 620, change is 20, equal to, multiplied is 2, times change in G is 10. So 10 times 2 is 20. So we can easily calculate this. Okay. Now I'm going to show you, I'm going to show you everything that we have so far discussed. I'm going to draw a diagram. In the previous chapter, I had drawn diagrams for aggregate demand and aggregate supply curve and show you the equilibrium. If you see, notice here, I'm going to delete this, but I'm just going to show you here. This was aggregate demand, if you remember. This is aggregate supply. This is price index. This is real GDP. And this is the equilibrium point, that is YE. Now we have calculated this YE actually using this aggregate expenditures model. So, but there's no aggregate supply. We haven't drawn this aggregate supply. So there's a slight different diagram. Let me delete this first. And now let's draw the diagram for aggregate expenditure. So this is, remember, I can show you here in all these equations, this equation, this equation, this, in all these equations, you will not find price index. There's no price. There's no even mention of prices here. So there are no prices. See, we haven't considered price. When I said we haven't considered price, I mean that price index is assumed to be constant. So we just assume that price index is constant. There's no inflation in the country. Prices are not increasing, just one fixed price. So I don't need to take price on the vertical axis because prices, I'm assuming, is not changing. So look at this diagram and you will understand what I'm trying to say. Here you have income. So you have Y on the horizontal. Why I have taken Y on the horizontal axis? Because I'm going to calculate here on the horizontal axis, right? Not on the vertical axis. It's difficult to read on the vertical axis. It's not impossible, but we will take Y on the horizontal axis. Why? Because look at this. Let me write here. Aggregate expenditure equals 300 plus 0.55. So aggregate expenditures is actually depending on Y here. So you know the dependent variable we take here, independent variable take here. Okay. Yeah. No. Aggregate expenditure function, and then your, yeah, so your aggregate expenditure function depends on Y. Yeah, that's fine. So this is independent and this is dependent variable. Even if you are confused with dependent and independent variable, don't worry. Don't worry about it, right? But what you have to do, remember, if I write consumption function was, I forget what that number was, 60, let's say 0.755. So this income is independent and your consumption will depend on your income. So you see when you draw consumption function is like this. So dependent variable is here, independent variable is here. So same rule we are applying here. Okay. So let me delete everything and redraw this screen diagram. So this is how we're going to draw this. Y, real GDP, and here we have aggregate expenditure. Now when Y equal to 0, aggregate GDP, and here we have aggregate expenditure. Now when Y equal to 0, aggregate expenditure equal to 300, right? Even if income is 0, then you have this aggregate autonomous aggregate expenditures. So I start from, let's say, 300 here. So we start here. And then 0.5 is basically nothing but the slope of this line. So it looks like this. So this is your aggregate expenditure. So aggregate expenditure is increasing as income increases. Okay. Now what I'm interested in to find this y. I want to find this y so that y and AE both are equal. You're getting my point? Let me take you an example, and then you understand. I can show you directly as well, but I'm just taking 5 to 10 minutes more, and then show you what is happening. Okay. Now let's assume that y is, let's say y is, I took intentionally 400. Suppose y is 400. Okay, that is your total, the value of total real GDP, total value of all goods and services is $400 million. Okay, now we calculate aggregate expenditures. We can calculate because we know consumption function, we know investment, we know government expenditure, exports, we know everything. So, and I've already deduced this final equation without 10, right? Don't worry about this 10. So we know that the 300 plus 0.55 is the aggregate expenditures. So I can easily plug here y as 400. So if I plug 400 here, what you get? Aggregate expenditure. So 400 times 0.5. 0.5 means half. So half of 400 is what? 200. And then you add this 300, 500. So if you go up on the diagram here, and if you read the value of aggregate expenditure when income is 400, you will see it would be 500. So this aggregate expenditure and this income, they're not equal. Income is 400, aggregate expenditure is 500. I want to find out income on the horizontal axis that will give me the same value of aggregate expenditure as well. You can check here. Let me mark this point. Let's take this point. Suppose this is 600. What this number should be here. So if you plug, instead of 400, if you plug 600, so half of 600 is 300, and then add 300, 600. So this is same. That is, we have calculated. But in diagram without any equation, how do I know that which point on this aggregate expenditure will give me the equilibrium income? How do we know? So the rule is simple. And the rule is you have to draw a straight line like this. See this. First, let me draw it. And this straight line is called 45-degree line. That is, this angle is 44. What is the definition of 45-degree line? Let me draw here. This is 45, suppose line, right? This is 45-degree line. By 45-degree line, I mean that I have drawn a line in such a way that bifurcates this first quadrant into two equal parts. So this line is exactly in between of these two regions, this region and this region, exactly two equal parts of the first quadrant. What is the meaning? The meaning is of 45-degree line that suppose I take any point on this line, any point. Let's take this point. And if I go down here and say, suppose if I say that this number is 10, then this number must also be 10. This is the characteristic of a 45-degree line. If this number is 5, then this number is also 5. They both are same. So when I draw this 45-degree line or superimpose this 45-degree line in this diagram, notice that 45-degree line is intersecting aggregate expenditure at 600. It means that this point and this point, they both must be same, 600. And that is our equilibrium. So even if I don't know numbers, I know where the equilibrium will lie. Let me delete everything and then draw a diagram without any numbers. So see what is happening. This is Y. This is aggregate expenditure. This is aggregate expenditures. Now I want to know what point will be the equilibrium point on this AE line. So I draw a 45-degree line like this. This is equilibrium. For sure, I know that this is equilibrium. Any income, so this is YE. Any income less than YE here, this is not equilibrium, because you can see you have income here, 45 degree here, and then actual aggregate expenditure is slightly higher. So below YE, to the left hand side, whatever be the income level, your aggregate expenditure will be higher, more than your income. Why? Because expenditure line lies above the 45-degree line. Any income above this YE equilibrium, you can see aggregate expenditure is more than the, or is less than the income level. So for example, if I take this number, let's say this is 900. Okay. So at 900, if you read aggregate expenditure, it must be less than 900. How do I know? Because 900 somewhere here, I know it's 45-degree line. This is 900. But aggregate expenditure is actually here, less than 900. So this is not equilibrium. Equilibrium will be achieved here. Okay. Now let's move to the next slide. This is not required. I just have given you this information that this is the notation that we normally use in the standard macroeconomic model. But you don't have to do this side. If you're interested, I will be more than happy to discuss with you on individual basis. This is the diagram that I just showed you earlier, and you can see that this is the aggregate. Let me mark this. So this is the diagram that I had earlier drawn. This is aggregate expenditure. This is the dark black line. This line is 45-degree line, although it's not written. Should be like this 45-degree line. And the equilibrium is here, which is not this. This diagram is not related to our example basically. So this is 1200. Okay. So equilibrium income is 1200. Now suppose there's an increase in investment instead of government expenditure by $100 million. So increase means this whole aggregate expenditure curve will shift upward by this amount of $100. Okay. So this is exactly, this distance is exactly 100. But notice what is happening. When aggregate expenditure shift upward by 100 because investment increases by 100, this distance is exactly 100. But notice what is happening. When aggregate expenditure shift upward by 100 because investment increases by 100, the 45-degree line intersects new aggregate expenditure, that is AE2 at this point, which is this. So equilibrium income increases from 1200 to 1600. What is the increase in income actually? $400. And you see investment increases by only $100. So this is 4 times. And therefore, the value of multiplier must be equal to 4. So 4 times this 100. So multiplier times change in investment will give you change in income. That is 400. That is why your income increases from 1200 plus 400, 1600. Okay. So just give me a second. I just want to make sure that, okay, that's fine. I thought they are going to discuss. No, so they haven't discussed. That's fine. Okay. Now, this is the derivation of aggregate demand that we already studied earlier. Because you know that prices are not given in this aggregate expenditures model. So we have to incorporate price as well. So what I've done here, if you notice that I have drawn 3 different aggregate expenditures curve. So one is AE1, then this curve, AE1, then AE2, then AE3. So instead of writing 40, although they have written here 45-degree line, they sometimes write like this, that Y equal to AE. This line, 45-degree line, is telling you that Y, which is on the horizontal axis, and AE on the vertical axis, they both are same on this line. This is the meaning of 45-degree line, right? Why we have 3? If you see in the bracket, prices are given. So I told you that whenever we draw one aggregate expenditures curve, that curve has one specific price. Okay. So at AE1, price level is P1. Okay. Now read this. A higher price P2 will lower expenditures. Of course, when price increases, you are going to demand less. You are going to spend less. So if price increases from P1 to P2, notice aggregate expenditures curve will shift downward. That is less expenditures. If price decreases, you are going to buy more. You are going to spend more. So aggregate expenditure will increase. What you have to remember in this diagram, remember this, that P1 is less than P2. Remember this, that this P2 price is greater than P1 and P3 price is less than P1. Okay. So once you know this, so I'm writing here. So this is basically the case. You have P1 price, then you have P2 price, and then you have P3 price. This is basically the case. That is, initial point is price P1, then one price P3 is less than P1, and P2 is greater than P1. Okay. Similarly, at all these three prices, you have equilibrium income. Okay, so at P1 you have Y1, at P2 you have Y2, and at at P3 you have Y3, and here you have Y2. What we are going to do, so let's see, you have three equilibrium income, Y1, Y2, Y3, and you can see that Y3 is greater than Y1 and Y1 is greater than Y2. So you know this. And similarly, you have three prices. Simple. You just plot prices and these aggregate expenditures. That is demand basically, which is shown here in this diagram. Notice, I wrote P1 in the middle because I told you that P2, this P2 is higher than P1. And P1 is also higher than P2. You also know that at P1, we have income Y1. At P2, we have income Y2, which is less than Y1. So that must be to the left. And then Y3 is the highest expenditures when price is P3. So you have 3 points. If you join all these 3 points, this is aggregate demand, which we have already discussed earlier. So see how we derive aggregate demand curve using expenditures or aggregate expenditures model. So I guess that's all as far as this topic is concerned. The relationship of consumption, saving, and investment to total income, the concept of expenditures equilibrium, how the multiplier effect applies to national income, the relationship of government, budget balance, and balance of trade to national income. We haven't discussed this. We will discuss in the later chapters. That is chapter number 8. And how aggregate demand results from aggregate expenditures. We have done this. So if you notice, I forgot to actually delete this. This should have been not here, this point, because if I take you here at the first slide, notice in the learning objectives, this point is not here, right? So we have all these points and then we drive. So that point was not given here. I intentionally remove that topic. Why? Because we'll discuss in chapter number 8. We'll discuss budget balance and trade balances well. Okay. Now, last thing, and that is your homework. If you want, you can do this, right? Remember that we know that multiply, the value of multiply, I'm writing here, the value of multiply. You also have to see the original slides from this chapter and read this chapter as well, because it is not possible for me to cover each and everything from the chapter. So this is your responsibility to go over all those topics from your textbook. So multiplier equal to 1 minus MPE. This is the value of multiplier, okay? Now let's take two values for multiply. So first take value of multiplier MPE, marginal propensity expense. Let's say this is 0.1. Okay, so if the value of MPE is 0.1, So what do you think? What would be the value of multiply? So you just write 1 and then divide by 1 minus 0.1, which is 0.9. Okay, so 1 minus 0.1 is 0.9. So you will get the value of multiplier is 1.11. Very small number. Very small number. The value of multiplier is very small. Why very small? Because your MPE is very small. So MPE and multiplier, they are directly related basically. Now let's take another example. Why not take the highest number? So MPE equal to 0.9. That is 90% of the income will be spent by consumers, by investors, and government and foreigners. So that would be, what is the value of multiplier in this case? 1 over 1 minus 0.9, that is 0.1. So 1 over 0.1 is 10. So 10 times. So if government expenditures increase by 1 million, then GDP will increase by 10 million. 10. So 10 times. So if government expenditures increase by 1 million, then GDP will increase by 10 million. 10 times if the MPE is 0.9. But if MPE is only 0.1, and if government increases its expenditures by 1 million, then GDP will increase by 1.1 million only. Okay, so you know the relationship between multiplier and marginal propensity to expend. So that's all as far as today's session is concerned. Thank you so much. Take care. Bye bye.